Hi everyone! In today's video, I'll be showing you the 3D object texture converter made by Digitalis Valosag. In short, the program loads the texture of a 3D object, analyzes it pixel by pixel with full precision, and converts the colors it finds into filament mixes, what we call pattern colors. Once that's done, we simply drop the resulting file into Orca Slicer, and from there we can do anything with it. Reposition it, rotate it, resize it, working completely freely with a full-color print-ready model. Let's go through step by step how it all works. Before we dive in, let's look at what files we'll actually need. Once you purchase the converter, you'll receive an HTML file. Simply double-click it, and the program's interface will open right in your browser. No installation or extra setup required. For the models themselves, we can use online 3D generator tools like Meshi or Tripo 3D. From those platforms, we can download the OBJ files we need, along with their matching textures. You can also use 3D scanned objects or even scanned people. Either way, these are the two things we need to get started: the object and its texture. Loading the model and texture. Let's load the object into the field in the top right corner of the program. As an example, we'll use a tiger model created with Meshi AI. As soon as it loads, the program shows us the model's resolution. In our case, 377,849 polygons. Next, we add the texture, which will give the tiger its fur pattern. Here too, the program shows the texture's resolution, 4096 by 4096 pixels. From our experience, this is one of the best resolutions to work with, though 1024 by 1024 also gives acceptable results. Since the program is essentially doing color mixing, it's important to understand how the settings affect the final result. Abal felso sa rockband talaljuk asin modokat. In the top left corner, you'll find the color modes. CMYKW. This uses black and white filament alongside the classic CMYK colors. Based on our own experience, CMYKWG gives the most photorealistic results when color mixing 3D models. CMYK for when you want to work with just 4 filaments without white. In this case, the program will let you know that fewer colors will be available for mixing. The program can also handle multiple objects at once. You can load up to 6 models in parallel, each with its own setting for how many colors are allowed to be mixed. This matters because when we mix a palette, 2 layers appear: the physical colors, which will actually be present in the slicer, and the mixed pattern colors created from them. For example, if we allow 250 mixed shades and process 6 objects at once, that budget gets shared across all the models. As a result, print time can be significantly reduced, since fewer fine color transitions need to be mixed layer by layer. How pattern color mixing works. Let's take a closer look at how the actual color mixing happens. Within whichever color mode you've chosen, CMYKW, CMYK, etc., the program can add or remove 1 color unit per layer within each pattern, in steps of 5. This is essentially a fine-tuning tool. If you're not happy with a particular color tone, you can correct it here. You can also add your own custom colors, up to 8 of them. For example, if you want to print a red parrot and you're after a bold, fiery red tone, you can add your own red, and the program will fold it into the mixing list. You can also add a support filament. It's best to set this up before loading the project file, because with certain formats, like PETG, the program won't let you expand the filament list afterward. Solid mode. The program also has a solid mode for anyone who doesn't want it mixing pattern colors and instead prefers faster print times. In this mode, no mixed pattern list is created. The program only chooses from the physical filaments you've loaded. It examines the color of each pixel in the texture and assigns it the closest matching physical color from the list. It's a conversion, not a mix. This mode is ideal for simpler models with fewer colors, a brown dog or a snowy owl for instance, and it speeds up printing considerably. It's comparable to Bamboo Lab's similar color mixing feature and works just as well alongside it. And calibration. Let's go back to color mixing mode. We'll switch to CMYKW for example. Once the texture loads, the program immediately starts sampling it. Here you can set how many pixels apart each sample should be taken. The lower this value, the more pixels the program examines, giving a more accurate, but more time-consuming result. Even at a sampling factor of 46, we already get an excellent quality converted texture. If that's not detailed enough, we can lower it to 4 times. At this setting, the program samples the 4096 by 4096 texture down at a 1024 by 1024 resolution, which takes longer to process, but delivers a more precise result. The maximum number of mixed colors allowed can also be adjusted here. The more shades you permit, the longer the final print time will be. The role of model resolution. The polygon count of the model itself is also a very important factor. From experience, an object needs at least 1 million polygons to properly display the fine detail of the texture, because the model's resolution directly determines how sharp the final texture will look. Even a high-resolution 4096 by 4096 texture won't help much if the object itself has a low polygon count. That's why the program includes a resolution multiplier setting. If your model has a low polygon count, say around 400,000, a 4 times multiplier can push it above 1 million, which is enough for color printing. Pattern resolution. Pattern resolution, default value 8 times, determines how many layers, that is, how many colors, a single mixed pattern can be built from. The higher you set it, the more colors can be blended within one pattern. This is especially useful for smoothly blending multiple shades on something like skin. Filament calibration. Any color in the filament list can be customized. For example, if your magenta filament looks a bit different in real life than the standard shade, you can pick the actual color with an eyedropper tool, or even enter a color code directly. The program will then use that exact custom shade for its mixing calculations, quantization, and conversion. Once we've set the color mode, the resolution, and the filaments, it's time for quantization. At this point, the program starts analyzing and identifying the colors in the texture, then shows you how many colors it could potentially mix. This number often exceeds the limit you've set. For instance, if it could mix over 300 colors but we've only allowed 255, the program will stick to that cap, which is usually more than enough. While quantization is running, it's worth taking a look at how the import into Orca Slicer works, but we'll cover that in detail a bit later. Once quantization finishes, the program gives you exact statistics. In our example, the tiger model ended up with a total of 248 mixed colors. Export. Once the analysis and color mixing are complete, it's time to click the Convert button. The program then generates the final, highly detailed model. In our case, a mesh made up of 1,111,396 points, resulting from the 4 times resolution multiplier we set earlier. After that, all that's left is clicking the Export button. The program automatically packages the result into a single 3MF file and downloads it to your computer. Importing into Orca Slicer. Now we're going to import this 3MF file into Orca Slicer. Open Orca Slicer, start a new project, and select your printer profile. This next part is important. Set up the filament colors to match those from the converter, and pay close attention to the order. It has to match exactly. Only after that should you open the 3MF file. Here, we don't use the regular import function, but the Open Project option instead. The slicer may warn you at this point that the 3MF file might contain custom G code. But you don't need to worry about that, since we'll be switching over to our own printer slicing profile anyway. Once it opens, you'll see that all the filaments have loaded, and the list of 5 physical colors has been preserved, in the same order as in the converter. The key point here is that we need to select our own printer profile. From this point on, the converter has no say in what G-code the slicer generates. That depends entirely on the printer profile you've chosen. From here, we can handle the model just as usual. Resize it in millimeters, rotate it, position it. The file isn't locked to any particular size or shape, and the colors show up beautifully on the model. When loading multiple objects, the program applies the same logic. The mixed color budget you set, 250 in this case, gets divided across the textures of all the objects. Pair print settings. The print process settings, layer height, speed, and so on, are completely independent of the loaded file, so you're free to set them however suits your own printer. The model can also be cloned. You can place up to 10 copies at once, all following the same color logic. Once everything is set up, all that's left is to click the slice button, and the program will start generating the print instructions. Tips and common mistakes. There are a few important things worth keeping in mind. The final printed colors match the colors shown on the loaded model itself, not the colors shown in the already sliced preview image. The shade you see in the slicer's preview can differ from the color of the actual printed model. It's worth keeping this in mind and fine-tuning your color settings if needed. For example, if one color ends up dominating the print too much, you can correct it using filament calibration. Lowering the layer height gives smoother layer transitions. It's worth dropping it down to 0.08 millimeters, for example, so the slicing comes out even finer and cleaner. The size of the model matters. The example shown here was only a 5 centimeter model. With larger objects, the level of detail and the color transitions can look even more impressive. Underestimating the polygon count is a common mistake. If the model's resolution is too low, even a top-quality texture won't produce a sufficiently detailed result. That's exactly what the resolution multiplier feature is there to fix. Summary. And that covers the full workflow of the 3D object texture converter. From loading the model and texture, through the color modes and pattern color mixing settings, all the way to quantization, export, importing into Orca Slicer, and finally printing. Thanks for watching. If you have any questions, drop them in the comments on my channel. I'll keep posting new test prints where I'll go through the conversion and testing process in more detail as well. See you next time.